It truly is a miracle metal. Steel, the most versatile, flexible, toughest stuff out there. And it's everywhere. In our buildings, our weapons, our roads, cars, and art. Even in our bodies. 90% of all metal made on this planet is steel. Want to impress friends with your razor-sharp wit? You don't need a PhD, because I already got one. Sink into the steel springs of your chair, because I'm about to rivet you to your seat and make you a steel genius. Hi, I'm Daniel Wilson, and I want to know everything. With a PhD in robotics, I tend to see the world a little differently. So I'm going everywhere, finding the hidden side of everyday things, revealing it all in The Works. Man's quest for the perfect shape has lasted 30,000 years. Flint, copper, iron, and bronze. Then, in the mid-1800s, the ultimate beard buster slices them all to ribbons. It's a razor made of steel. That's a sharp-looking blade. Steel. It originated in East Africa. It's the core of advanced human civilization. You know, steel's really only iron, with just the right amount of carbon. It's like alchemy, really. The magic elements, iron and carbon. They strike a perfect balance between strength and flexibility. The story of steel is a mind-blowing journey through space and time. A trial by fire to the extremes of 3,000 degrees Fahrenheit. For more than a century, steel's been lifting us skyward. From the first 138-foot skyscraper built in 1885 to this 1,700-foot monster. But it's not just buildings. We live in a world of steel. Mankind produces 1.3 billion tons of it a year. That's 500 pounds for every person on the planet. Together, China, Japan, the United States, and Russia make 50% of the world's supply. Asia uses the most steel, whereas Africa uses the least. Pretty surprising, since Africa was where steel was first discovered. 3,000 years ago, they had the monopoly at a time when steel was more precious than gold. It gave its owner an edge, literally. Archaeologists tell us that the first steel tools were weapons, honed to a killing point. And even today, steel is still the material of choice for master forgers. I'm still thinking blades, and there's nothing sharper than a samurai sword. The secret to steel's miraculous combination of iron and carbon was perfected in 10th century Japan by samurai sword makers. But now it's nearly a lost art. I'm calling on one of a few masters left, hoping he will reveal the secret. We're on our way to meet the most unlikely samurai sword maker you can imagine.
Pleased to meet you. Come on, let me show you my shop here.
Okay. Louis Mills has been making swords for over 30 years. His handcrafted weapons sell for thousands of dollars a piece. The process of making a samurai sword takes months of painstaking, back-breaking work. Today, though, Louis is going to let me try my hand at some basic sword making. So this is the first thing you do when you make a samurai sword?
I have to make the steel.
Got to make the steel. So what do we just pour in there?
We poured in pure iron. It's 99.9% pure iron.
But it looks exactly and feels exactly like kitty litter.
I don't think the cats would enjoy it.
Time for Steel Making 101. The big breakthrough that led to steel was the discovery that blowing air into an open hearth, charcoal-fired furnace can generate heat sufficient to melt iron ore. Above 2,700 degrees Fahrenheit, the bonds between iron molecules break, allowing the iron to shed any impurities and bond with carbon atoms. As the hot liquid cools, the carbon and iron realign to form a lattice, a much stronger molecular structure. The carbon content of most steel is a mere 1% or less. But carbon is also the main fuel that powers steel smelting furnaces.
So you need charcoal to make barbecue and samurai swords. Oh, that just exploded in my face.
Forging steel pure enough for a samurai sword is problematic, even for a pro like Louis.
In my work, I have about a 25% success rate. 1 out of every 4 blades that I make, if I'm lucky, will survive.
Wow. This whole blade could be ruined right now?
Oh, yes, very easily, within a second.
Creating a samurai sword is a painstaking ritual of purifying the steel. Heating, pounding, folding, then reheating.
So this is the folding process that you always hear about
Yep.
with samurai swords. They say, oh, it was folded 100 times. Now, what does all the blade folding do for the blade?
It refines the steel, distributing the carbon evenly through the whole blade.
Time for me to try my hand. Pounding a raw hunk of steel like this into a blade takes thousands and thousands of hammer blows. We won't bore you with all that. Luckily, Louis is ready with his Iron Chef move and miraculously pulls a finished one out of the oven.
Now it looks like a sword. That is to say, it looks like you could stab it into somebody.
Well, you don't want to do that.
Now the riskiest step. Heating the blade, then quenching it in cold water. If Louis's done everything right, the blade will curve, taking on the iconic form of the katana. But the tiniest impurity could destroy months of work. Louis's an old school guy. No gauges, no digital temperature readouts here.
We just got the lights turned off because the only way to determine how hot it is by looking at it. He is not afraid of the fire.
Yes, I am. I respect the fire.
Yeah.
Listen to the rhythm of what I'm doing here, okay?
This sounds like a creature breathing.
Yeah, it is. It is a creature breathing. Okay, coming out.
Moment of truth.
This time, Louis's years of expertise pay off. The blade holds. The shape is perfect.
That's what I wanted it to be.
Well, we're good so far.
So far, we're good. Hopefully.
Yeah. Dodging hot slag, wearing gloves, putting on stylish eyewear, it's all well and good, but I want to see one of these babies in action. Hey, hey, hey.
It was said that a samurai's soul was in his sword.
Hey! Hey!
Considering it takes months of constant labor to deliver one of these babies, that makes a lot of sense. The status their steel swords gave the samurai in feudal Japan was so great, they were permitted to behead a commoner merely for offending them.
Messy. Today we followed steel blades from their creation to their application, when those grass mats felt my wrath. My mighty, mighty wrath.
Samurai swords are powerful because they combine two different types of steel. On the outside, the super hard stuff that holds an edge. On the inside, a softer formulation that gives flexibility. The genius to steel is in this amazing diversity. And there are thousands of other types of steel with even more uses. We've already used 8 billion tons of it since 2000, and it's virtually indestructible. Truth is, yesterday's slinky becomes today's super armor.
They gotta shoot right now.
Fire in the hole!
So many different kinds of steel, over 3,500 in all. Carbon steel, stainless steel, chromium steel, electrical steel. Yet every type of steel is made from the same material, iron and carbon. Other elements are added to create different steel alloys, but the basic recipe is the same. Carbon steel enables the cables on suspension bridges to sway in the breeze and hold up hundreds of times their own weight. Steel doors are fireproof and provide 10 times more protection against intruders than wooden doors. Canned goods need no preservatives. Steel does all the work. The chromium steel on your toaster enables you to keep it clean and see yourself. Your car's safety cage, the cutlery you eat with, power plants, power tools. You guessed it, steel. Mankind was refining steel 3,000 years ago in China, India, and Egypt. They made steel from iron meteorites they called metal from the sky. Heating the iron ore to the 2,500 degrees needed to force the carbon out was difficult. Open fires only reach about 1,000 degrees. So they raised the temperature by blowing in oxygen from the side to fan the flames. In the Middle Ages, forgers discovered the bellows. They used it to pump air into the fire, raising its temperature. But steel was still rare and precious, reserved for swords and armor. But then a breakthrough. In the late 1850s, Henry Bessemer unlocks the great mystery of steel. He discovers that by blowing cold air into the bottom of the fire, it can heat the iron to over 3,000 degrees, enough to blow off the carbon, converting the iron to steel. This is a huge breakthrough for industrial production and especially for rail travel. Iron train tracks rust easily and are vulnerable to rapid changes in temperature. This makes them crack and buckle, causing frequent accidents. But steel tracks are more flexible and durable. This makes train travel safer. And mass production of steel makes factories possible and power easier to produce. But I still want to know where all that steel from all those trains and 19th century stuff went. Is it buried somewhere? Turns out, it's right here, all around us. I've come here to Coatesville, Pennsylvania to learn more. This scrapyard supplies used steel to ArcelorMittal, a steel company that operates in 60 countries, producing 10% of world output.
Basically what we do is heat it, beat it, and treat it. Take steel, melt it, change it into different shapes, shape of plates, heat treat it to get the properties, and then sell it to our customers.
Scrap comes from old cars, trucks, bridges, buildings, appliances, anything that was made out of steel. Here's another secret to steel. It never dies. It can be recycled repeatedly without losing strength.
Oh, check it out. Somebody threw away a perfectly good bike. Luckily, it's about to be recycled. It'll all be over soon, little buddy.
Here's where the magic happens. The scrap is melted and reformed into these hot slabs. Here, they throw the whole frying pan right into the fire. Instead of using primarily coal or coke, ArcelorMittal uses electric arc furnaces. Less energy is needed, and less toxic byproducts like sulfur dioxide and hydrogen sulfide are released.
Recycling steel is a big deal. For every ton of steel you recycle, you save 2,500 pounds of iron ore, 1,400 pounds of coal, and about 120 pounds of limestone.
Why avoid the limestone? Because when it's used to burn the slag off molten iron, it releases toxins like sulfur and phosphorus. Fortunately, this step is bypassed here.
So can you describe the overall process for me?
This piece of steel is coming through the descale box. The high pressure water will clean the surface.
Whoa! What's this prehistoric machine doing to that piece of red-hot steel?
It's exerting up to 10 million pounds of pressure to make it thinner, longer, and wider.
So those are just like gigantic rolling pins, and it's using steel
does the dough.
Yes.
Why are they coating it in water?
The water knocks the oxide off of it, the scale that forms.
Okay.
And if we don't knock it off, it'll get pressed into the surface.
Make it impure.
Yeah.
This is the most impressive car wash I've ever seen in my life.
Guess which material is recycled more than aluminum, glass, paper, and plastic combined? Yeah, it's steel. You're watching a show about steel, so it stands to reason that that would be the answer.
So, whatever happened to that bike I saw out in the scrapyard? It's been transformed into these super tough, high hardness steel plates.
Those plates are used for the armored program, especially the Humvee vehicles and the new MRAP, to provide ballistic protection for those vehicles.
But what makes the recycled steel that comes out of this process different than what went in? He tells me that when the scrap is melted down, chromium and nickel are added to it. Next, they roll the recycled steel into sheets, pressure and heat treat it, and cut it into plates. The infusion of chromium and nickel, plus the extra pressure and heat treatment, creates a completely different alloy. A super steel that's more rigid and shock resistant. Perfect for armor plating. To find out how strong it really is, I've come to Alpine Armoring here in Dallas, Texas.
Whoa, look at the size of this monster. Hey, you think I could drive?
Sure. I'll take shotgun.
All right.
Attention! Fun fact to know and tell. The term to sit shotgun comes from the armored cars of the Wild West, when a guard would ride on top of a stagecoach, armed with a shotgun. End of transmission.
This is a smooth ride. How fast does this thing go?
Get it up to 80 miles, 90 miles an hour.
So what's this truck that we're in?
This is a SWAT truck, as you can see, is built for the law enforcement police community in case they need to go after some cases that require attention.
Yeah. How many tons of steel are in this vehicle?
Well, believe it or not, you're driving a 12-ton truck. I know it doesn't feel like it, but there's a lot of steel there.
Is the steel especially made to be bulletproof, or do you just get it as thick as you can?
Oh, absolutely. This is not your regular steel at all. Half-inch steel all around the opaque area, roof, floor, sides. This is a hardened ballistic steel.
What's the difference between this vehicle and an armored car that's used to protect cash?
A typical armored cash-carrying truck that we all see every day in the street looks like a very comprehensively armored truck, but essentially it's a level A3, A4, which means stops handguns.
So on the level of A1 to A10?
This is A10.
It's a smooth ride. I can feel the inertia from this 12 tons of steel that I'm wrapped in. And yet, Fred, how do you know for sure that this thing will stop bullets?
Well, Daniel, if you don't mind, right after you're finished driving, we're going to stop and shoot this truck with you and I in it.
That makes a lot of sense. I'm in. I'm cool. I don't have any problem with that. What are they going to shoot at the vehicle?
Oh, you don't want to know.
Turns out,
This looks like a cartoon drawing of a tool.
there's a softer side to steel.
I can assure you it's real.
To be a steel genius, you have to know its limits. Even a super metal has a weakness. That's why I'm about to risk my life to test the limits of steel.
Now I'm gonna put my life on the line to see if steel can stop bullets. So apparently Fred was serious about us getting shot at while we're in this armored vehicle.
Fire in the hole!
They're, gonna shoot now.
They're going to shoot right now.
My survival depends on how much kinetic energy this steel armor can absorb. Should I be nervous? Let's rewind for a second. The bullet travels at 3,200 feet per second. That's almost 2,200 miles an hour. All that energy will be instantly released on impact. The bullet mushrooms, deforming as its energy transforms to heat. Why does that happen? Well, as you recall from Louis' Samurai Workshop and the recycling plant, heat softens steel and causes it to expand. The steel absorbs all of the bullet's kinetic energy. I'm still here.
There it was.
Surprised?
That wasn't as bad as I thought it would be. I, for instance, wasn't shot, as far as I can tell.
We know the steel in this truck is tough, but it's not perfect. It's still vulnerable to explosive-tipped bullets or rocket-propelled grenades. These weapons release more heat on impact. It's called the pyrophoric effect. When the projectile hits the tank's armor, they both partially liquefy, which can penetrate the steel. Being hard has limitations, but what about steel's other defining characteristic? Its pliability. Lowering the carbon content of the steel makes it more pliable. Stainless steel cutlery only has 0.5% carbon. That's why you can bend a fork. But what if you wanted to build a 140-foot steel monument to humankind's aspirations? What material would you use? That was the problem facing the 1964 World's Fair planners.
What stronger, more durable, and more appropriate metal could be thought of than stainless steel?
Thousands of pieces of stainless steel had to be bent to precise specifications so every piece could be welded together to form a perfect sphere. Despite its 450-ton mass, the Unisphere appears to float weightlessly and still looks as new as the day it was completed in 1964.
It's not steel, it's art.
But who's pushing the outer boundaries of steel's plasticity today? To find out, I've come to Rochester, New York. Sculptor Albert Paley has spent 30 years perfecting his steelworking skills.
Steel has incredible versatility. So what is steel capable of and what can it do? Obviously, we know it's a very strong structural material.
A lot of people think of steel as hard, rigid industrial material, but when you heat it up, it takes it back to its original state, which becomes very plastic and very fluid.
Yeah.
And we try to accentuate that fluidity with the sculptures.
How does Albert do it? He starts with low carbon, or mild A36 steel. A structural steel commonly used in I-beams because it's strong but flexible. Albert's crew uses oxyacetylene torches for the welding. These are propane-fueled heating and cutting tools that use oxygen. Get it? Oxy. To generate 2 million BTUs of heat.
As it gets hot, the iron expands and the molecules expand, so it becomes much more flexible.
Right.
You can overheat it and actually burn the structure of the metal. And when you burn the structure of the metal, lose all cohesiveness and it just falls apart. So we have to keep it into a good range.
Okay, so on this gate, this is what it's supposed to look like at the end. This is what we've got, this big tweezer. How the hell are we gonna go from this to this?
All right, each one of these bends that you see will be an individual heat.
Okay.
So we'll take a bend and we'll just keep on working this and weave it through.
I understand that theoretically. I'm still gonna have to see it to believe it, though.
No, more than seeing it, you're gonna be doing it. So
I'm gonna have to do it to believe it.
This gate has 180 pieces of steel, all of which need to be cut to precise specifications, shaped, and welded together. When completed, the gate will weigh 10,500 pounds. Unbelievable! Albert tells me that a project like this usually takes at least a year to complete, with up to 100 people working on it. But what does it all mean? Turns out, everything we've learned about steel behind the scenes is exactly what Albert's trying to hide.
You know, the steel is quite heavy, quite massive. What I try to do with the designs is to kind of belie that sensibility. So when you see this, it appears very light and very fluid, as if gravity is not dealing with this.
And what could be lighter than a bird in flight? Albert's latest project, a giant 5,500-pound steel eagle.
This looks like a cartoon drawing of a tool. But no, I can assure you it's real. Making art. My knuckles are burning up. You are completely nonchalant about this process because you've been doing it for 30 years. I'm pretty sure I almost died. I am slowly catching on fire.
You want to pull that over so I touch it.
Yeah, there's not really any communicating down there. So you...
Well, you did it. How did you communicate?
I don't know. Every command you gave me was the same. Ah! Like that. And then sometimes you'd wave your hands at me.
Yeah, where you got the idea?
I'm either doing really good or really bad. I never thought that art would take such a physical toll, you know? It's amazing, actually. I'm out of breath from making art. There's no better way to be.
The genius of steel has a dark side, too.
You've got a whole torture chamber for metal out there.
Steel's amazing. It's able to lift tall buildings from the ground, stop a speeding bullet, even leave our planet behind. It really is a super metal. But even steel has its kryptonite, its fatal flaws. Sometimes steel fails. And when it does, lives are at stake. Researchers at the Atlas Center are working to make sure this doesn't happen again. This place is like CSI, but the forensic investigations taking place here are for steel.
What do you do here?
Well, this is an example of the kind of thing we do here. This is part of a structure that was originally 4 stories tall. Here's one of the columns, and imagine 2 more.
Okay.
We subjected this structure to simulated earthquake loading, and you can see the results. Although there's quite a bit of deformation here, the structure still remained safe and standing.
Every machine in this massive lab is built to do one thing: test steel.
Richard, what is this big creaking monstrosity?
Well, this is a box kind of structure that's composed of some steel framing with some fiber composite panels in it. And you're looking at some of the instrumentation we're using to measure the deformation in the panels.
So as this panel stretches out, this little guy, you can just see it's moving just a little bit.
Just ever so slightly.
And it's sending that data through this cord and off to a computer. Should I be worried about this really ominous noises that are coming from this thing?
Yeah. In fact, I'm surprised, actually, when you look at that, you can see quite a bit of motion.
Basically, Richard tests new kinds of steel by applying extreme pressure to it, stressing it day after day. That's the thing about science. It's so time-consuming. How long are you gonna let this go?
Well, the test we're currently running takes about a week. In that time, we apply about 100,000 cycles.
Each cycle stresses the steel by applying pressure to specific target points. We depend on the strength of steel every day, but rarely are we aware of its limitations. Potential disasters lurk under our feet and hang above our heads all the time. Even steel has a breaking point, and it's Richard's job to find it.
This looks like a light pole. Am I wrong?
It is a light pole. In fact, this is a type of structure that we would use to hang a signal out over an intersection. What would happen when the wind blows, it'll make the mast arm vibrate up and down. As it vibrates up and down, it induces stress in this connection and in this connection here.
Now, do you put sensors on this thing, or do you just wiggle it back and forth until you find cracks?
Well, you see we have some strain gauges here, and we're using that to determine the stress in the pole, and we can actually see some cracks. Where the mast arm is meeting this base plate on the top,
Right.
There's quite a substantial crack that's certainly visible and worth looking at.
Yeah, that is really obvious. What's with all the red paint?
Well, that's part of our process for being able to identify the crack, especially when it's very small. It starts as a small crack and gradually grows. We use that as a penetrant to help mark the crack or make the crack more visually observable.
Wow.
Repeated stress, such as wind or vibration or load, can cause metal fatigue. That's right. The steel itself gets tired over time. A microfissure forms at an atomic level, dislodging a few molecules to form a tiny crack. If left unchecked, the splinter widens. Then, all it takes is a catalyst for the steel to reach its breaking point. Earthquakes, floods, hurricanes, terrorist attacks. These events create conditions that push steel to the limit and beyond.
You've got a whole torture chamber for metal out there. You're recording every little thing that happens to it, and it all goes to these computers. What are you doing with all that data?
We analyze it, study it, take it apart, look at it in detail, try to figure out how to make the structures perform a little bit better.
So you torture the metal, collect the data, analyze it, and then make the metal better, and you make the world a safer place.
Exactly.
Tough love for the steel.
1940, the Tacoma Narrows Steel Suspension Bridge. You've seen the footage, right? What happened? The force of the wind didn't destroy the bridge. Instead, the pulse of the wind was responsible. It turns out the shape of the canyon caused the wind to blow in gusts. The frequency of the gusts coincidentally matched the frequency of the bridge. The waves amplified the bridge's vibration to the breaking point, pitching and rolling, finally shaking itself apart. This phenomenon is called sympathetic vibration. Now for the good news. Sympathetic vibration actually makes steel ideal for creating music. Makes a lot of sense. I want to know more, so I'm on my way to Dallas, Texas to meet a master of metal. Guess again.
1, 2, 3, 4.
Professor Joe Perea not only makes steel drums, he uses them as acoustic laboratories for his students.
This is just a regular steel drum?
That's right, just a regular container barrel, just an ordinary 55-gallon oil barrel.
What does one of these cost?
It depends. If you buy brand new, you can get them for $15 to $30. If you use used oil barrels, certainly sometimes you can get them for free.
Steel drums were invented in 1940s Trinidad when people started recycling discarded oil barrels.
All right, let's get to the good part. Time to get hammered. Earplugs, ear protection, please.
What gives steel drums their unique, mellow, echoey sound? You guessed it, sympathetic vibration. Just like the old tuning fork experiment. Two identical tuning forks, one on a wooden box. I strike the other one, place it on the box, mute it, the unstruck tuning fork sings. It's not magic, it's vibrations moving through the air. How does this work in the steel drum? The instrument literally sings to itself, creating a ball of vibrations that travels outward from the point struck.
So how do you figure out which note you're going to get just based on the dimension of the piece of steel?
A set of measurements that'll tell me this particular note needs to be, 5.5 inches along
really?
the outer rim, and then it needs to be radially into the drum approximately 6 3/4 inches.
So based on the dimensions of these little surfaces, you get different notes. And
Absolutely. So the finished product, as we come over here to this drum, you'll see where we have our bank of rim notes and then our inner octave of notes.
So what features of the steel affect the final sound?
If you think of a flat spring that you would see as the suspension system on the back of your car, it would be something like this. And so when you applied load on it, it would flex and come back up. In this case, it's a little bit different. You're going to have a little bit of curvature on the short axis, and you're going to have a little bit of curvature along the long axis as well. All these tension points that we're creating here is going to create this sort of elasticity that's going to hold the note in check.
You're building different springs into
That's
the surface.
exactly what's happening.
Wow.
Steel drum heads can hold up to 30 different pitches, and that means 30 springs. That's a lot of tension for a sliver of steel less than 1 millimeter thick. To make the drum head stronger and more resilient, Joe heat treats it with an acetylene torch.
Get cooking.
Without this heat treatment, the steel in the drum head would be so unpredictable, the drum wouldn't hold its pitch.
Little sizzle here.
After he finishes quenching the red-hot drum head, Joe invites me to take one of his homemade drums for a ride.
Your turn.
Okay.
Visualize, Daniel. Sandy beaches, drinks with little pink umbrellas, the rhythm of the islands pulsing through your veins.
Someone put too many notes in here.
Needless to say, Joe demotes me to something a little more my speed. The acoustic properties of steel can make beautiful music and, as we've seen, horrible destruction. Steel has some miraculous qualities.
Ow! That is a serious problem.
Sometimes it can be a real savior. My journey is almost complete. We know steel's combination of strength and flexibility supports the world around us, but the final frontier might be the most surprising. Inside us.
I'm always aware of the steel that's in my body. I can either taste it or I can hear it like clanging around. It's just something that's always with me. It's a sensation for sure. I like it.
She's not alone. Today, more people than ever are getting body piercings. A process dating back thousands of years. It wasn't always a safe proposition, but there's a final property of steel that makes it a miraculous metal. It's sterile.
There's no piece that heals better and more efficiently than surgical steel.
Surgical steel is a type of stainless steel, which was invented by metallurgist Harry Brearley in 1913. He discovered that adding nickel and chromium to steel created a metal that won't rust. He called it stainless steel. Perfect for cutlery and instruments. These days, piercing enthusiasts are limited only by their imaginations and the disapproval of their mothers.
For all piercings, you're going to use steel because it's non-porous, they won't collect bacteria. Because it's strong, it's not going to corrode. I don't take out my body jewelry, I leave it in, so it's, pretty much just becomes a part of me.
Steel forms the skeleton of our cities, holding up buildings and bridges, reinforcing roads and overpasses, and bringing us electric power. But it's also the metal of choice to repair the human skeleton. Orthopedic surgeon Dr. Kenneth Rodriguez explains to me why our bodies don't reject steel.
Stainless steel is a very biocompatible metal. It is the chromium component of stainless steel that creates a layer of chromium oxide over the implant by a process called passivation. This layer minimizes corrosion and corrosion byproducts.
So it doesn't rust?
Correct.
Myth or fact? Stainless steel cannot corrode.
free iron molecules on the surface of stainless steel can lead to corrosion inside because iron reacts with water to form rust. So how can we put it in our bodies? Dipping stainless steel in nitric acid removes impurities, forming an invisible film of chromium oxide on the surface, preventing contamination and corrosion. The steel is made passive. And for reasons scientists are still not sure of, this coating has the spontaneous ability to repair itself.
So Daniel, this is a typical example of the kind of fracture we would treat with a plate. We're using this stainless steel plate that has screws going into the head. You can see them right there. Try to grab as much of that bone as possible. Let me show you something, Daniel.
This is a standard set of surgical orthopedic plates.
So when is steel the best material to use?
Steel is usually used when you want to fix a fracture with some degree of rigidity. Stainless steel has the highest rigidity of most metals used in implants.
Remember how Richard at Atlas explained metal fatigue? It can happen inside your body, too.
Ow! What happened here?
This is a failure of a plate.
The metal can actually fatigue while it's inside you?
Like any other piece of machinery.
But you would think it would last for as long as a sheet of armor or something.
It's quite remarkable. It can last for about 6 or 7 months before it breaks, but it will eventually break.
Wow.
Just think about it. You can take any significantly large piece of metal and gradually bend it 1,000,000 times. And the day will come when it will snap like a twig.
So it's a race between the steel plate and the bone. If the bone doesn't heal fast enough, then the plate will eventually break from metal fatigue?
Absolutely.
Even steel is bound by the laws of physics. But its failures are far outweighed by its versatility. Steel is truly man's best friend. Okay, we've tested your metal, but you're not a steel genius yet. Pop quiz. What was steel first used for? A cutting tool. 3,500 years ago, man invented the first steel blades. So our journey takes us full circle. Back to the blade, to the Lamson and Goodenow knife factory, where the timeless properties of steel meet the cutting-edge technology of robots?
This is our Burger robot grinding cell. The robot we've had for 3 years, and what had taken 3 men 10 minutes to grind a knife now takes our robot 30 seconds.
Here, future meets past. The genius of steel lies in its constant reinvention.
Our high production laser has replaced a century-old stamping process. We can now cut thousands of pieces an hour versus what had taken many hours of manual labor and dangerous labor.
But even with all the high tech, the best knives still require the human touch.
So every knife that we make is from the grinding process on is hand finished. The knives are tapped in by hand. We move it into the handle finishing process, really giving them that beautiful hand feel and hand finish.
There's something I've been dying to know. Can you shave with a Lamson sharp knife?
You could definitely shave with it. I wouldn't recommend it, but yeah, you probably could shave with a Lamson knife.
Men first shaved with flint, copper, bronze, iron, and now steel. For 3,500 years, men have been obsessed with this miracle metal. Strong, sharp, durable, infinitely malleable, flexible, hard. Steel is whatever we need it to be. That is the genius of steel. From swords to scalpels, skyscrapers to the slinky, steel supports us, surrounds us, even inspires and amuses us. Now that you know all this, you are a steel genius.